Assalamualaikum warahmatullahi wabarakatuh. We from group 4 will present about water pollution in Sungai Semenyih. These are all of the list of content that will be in our slide. And these are our group members. My name is Marina Jamil Kamaruddin, so I will proceed with the first element, which is introduction. So Sungai Semenyih is known as an important river because it supplies raw water to the Semenyih water treatment plant, which it provides water to a large population in the Klang Valley. However, since 2020, water treatment operations have been stopped several times due to strong and unpleasant odors in the river. According to Air Selangor, unusual chemicals were detected at the raw water intake, making the water unsafe for treatment. Next, types of water pollution. There are three main types of water pollution identified, which first, improper discharge of industrial effluent. Some factories upstream release untreated or partially treated wastewater into the river, and this introduces harmful substances and directly affects water quality. Next, organic and chemical pollution, which industrial chemicals such as volatile organic compounds, or known as VOCs, and organic waste produce strong unpleasant odors and disrupt the water treatment processes. And the last one is nutrient pollution. Excess nutrients like nitrogen and phosphorus enter the river from sewage, detergents and runoff. These nutrients reduces oxygen levels and worsen odors problems in the river. An integrated solution is necessary because multiple factors and stakeholders are involved. First, stakeholder involvement. There are a lot of parties that involved in this particular activities, which first local communities, industries, wastewater operators and else. So cooperation allows pollution sources to be identified early and effective solutions to be implemented together. And second, nature-based solutions. So nature-based solutions such as constructing wetlands and river restoration will help improve water quality naturally. And third, innovative technologies. Innovative technologies like real-time water quality monitoring and early warning system help detect pollution quickly. And these tools allow authorities to respond faster and prevent repeated pollution incidents. Next, we will move to the causes of the water pollution. There are three main causes of pollution in Sungai Semenyih. First, physical causes, which it includes land use changes and industrial development upstream. During rainfall, surface runoff carries oil, waste and sediments into the river due to poor drainage systems and lack of buffer zones. And next, chemical causes, which are the main contributors to water pollution. Industrial effluent containing solvents, detergents, ammonia and hydrocarbons produces strong smells and disrupts normal water treatment processes. And the last one is biological causes, which occur when high levels of organic and nutrient pollution promote bacterial activity under low oxygen conditions, which it leads to the releases of gases such as hydrogen sulfide and methane, which it will worsening odor problems and threatening aquatic life. Next, we will move to the impacts of the pollution. First, environmentally, reduced oxygen levels and toxic substances will harm aquatic organisms, which lead to the fish deaths and loss of biodiversity. Next, socially, communities experience frequent water supply disruptions and discomfort due to unpleasant odors and reducing public trust in water authorities. Next, economically, which water treatment costs increase and businesses and households suffer financial losses during water shortages. Last one, health impacts, which exposure to odor causing gases such as hydrogen sulfide and ammonia can cause headache, nausea, dizziness and respiratory irritation.
The first engineering intervention focuses on controlling pollution transport pathway through a strategic in-river seed trap system. These silt traps are installed at upstream tributaries and industrial drainage outlets to intercept sediments and particulate-bound pollutants before they enter the main river channel. The system operates based on flow velocity reduction and gravity sedimentation, allowing heavier particles to settle during storm events. The design follows MSMA principles and is sized for 10 to 20-year average recurrence interval rainfall, with proper access for routine maintenance. By reducing turbidity and suspended solid at an early age, this solution protects downstream treatment facilities and support the river's self-purification process. In terms of sustainability, it directly contributes to SDG 6 by improving raw water quality and SDG 11 by enhancing urban water infrastructure resilience. The second engineering solution targets chemical and biological pollution through advanced filtration. The system is implemented as a raw water treatment stage and adopts a multi-barrier approach, combining membrane filtration, activated carbon absorption, and biological filtration. Membranes physically remove fine particles and microorganisms. Activated carbon absorb odor-causing and toxic compounds, and biological filters degrade organic matter. The system is designed in accordance with WHO Drinking Water Guidelines and Malaysia Ministry of Health standards, with a modular configuration to allow operational flexibility. This approach improves water treatability during pollution spikes, reduce odor-related shutdowns, and increase supply reliability. It supports SDG 6 by ensuring safer water abstraction and SDG 9 by promoting resilient and innovative infrastructures. Engineering solutions alone are insufficient without strong governance. From a policy perspective, stricter enforcement of the Environmental Quality Act 1974 is required, including tighter compliance audits and heavier penalties for illegal industrial discharge. In addition, mandatory riparian buffer zones of 20 to 50 meters should be enforced to limit high-risk activities near the river corridor. These measures prevent pollution at the source and reduce over-reliance on downstream treatment. This policy framework supports SDG 6 through pollution prevention, SDG 11 through sustainable land use planning, and SDG 16 by strengthening institutional effectiveness.
My name is Nur Shafizani binti Muhammad Jafri. Next, I will evaluate the proposed solution for addressing pollution at Sungai Semenyih. This evaluation is based on effectiveness and feasibility, cost and resource efficiency, sustainability in environmental, social and economic aspects, as well as compliance with legal and safety requirements. The first engineering solution is in reverse trap and sediment control system. In terms of effectiveness and feasibility, the system is effective because it reduces flow velocity and allows gravity sedimentation, preventing pollutants from reaching downstream water intakes. It is also feasible as similar systems are already applied in Malaysia's water management. Regarding cost and resource efficiency, the construction cost is moderate and the operational cost is low. Maintenance mainly involves routine visiting, which requires minimal energy and resources, making the system efficient and in the long term. In terms of sustainability, environmentally, the system reduces turbidity and total suspended solids, supporting the river natural self-purification process. Socially, it protects communities that depend on Sungai Semenyih for water supply. Economically, it lowers treatment costs by reducing pollution loads entering water treatment plants. The system complies with the manual saliran masa alam, fulfilling legal and safety requirements, and support SDG 6, clean water and sanitation, and SDG 11, sustainable cities and communities. The second engineering solution is the advanced filtration system at the raw water intake. In terms of effectiveness and feasibility, the system is highly effective as a final protective barrier, although it requires skilled operation and continuous monitoring. For cost and resource efficiency, the system involves higher capital and operational costs. However, it significantly reduces emergency shutdowns of water treatment plants, resulting in long-term economic benefits. From a sustainability perspective, environmentally, it prevents contaminated water from entering the supply system. Socially, it ensures a safe and continuous water supply for consumers. Economically, it reduces losses caused by water supply disruption. The system complies with pre-drinking water quality and safety standards and support SDG 6, clean water and sanitation, as well as SDG 9, industry, innovation and infrastructure, by promoting advanced and resilient water treatment technologies.
So that's all from us. Thank you.